are two receptacles in this single yoke, so the calculation will still be 180. Okay, so that is the minimum required. Okay, so ang exception lang is that, so it's also mentioned here that there's an exception if there are 4 or more receptacles. So that's the time that your calculation will be per 90 VA. Let's say we have here, um, let's just have here 6, for example. So this will be 90, this is 90, so therefore the total VA will be 90 times 6. Okay, so wala siya ang calculation. So that's the only exception. No? So for receptacles having 4 or more, um, 4 or more receptacles. I mean outlets having 4 or more receptacles. Okay, so where this one, so since duhaman lang ni siya, and it's located in the same yoke or single strap, so therefore 180 lang gyapon ang calculation. Okay, so therefore sa ito siya akong gi-instruct sa inyo, so I have to correct myself para dili sa mo ma-lead to wrong belief. But actually mo gani siya gitulo sa ako sa una, so when I was a student, that you have to multiply it by 2, okay, making it 360 VA. So probably I haven't checked sad because at that time the electrical code was older pang version. So probably what we're using that time was the 2018, but I don't think no nga it has changed a lot. But probably sa episode na na-instructs ako okay, so that is I'm using 360. But even if you are using this it is still safe. So probably he knows no nga because he is a seasoned, he's not actually a faculty, but he's a seasoned designer in electrical system. So probably he enough for what do you call that, for demand calculation. So mo na siyang ihang multiply by 2 just to accommodate for more loads. Okay, so that he will also be safe as an electrical practitioner, because every time you increase this one, so meaning you are limiting the number of outlets per branch circuit. But if we are to follow strictly the code, so we can use 180. But again, this is fun. This we can still use this. Okay, so because this is safer. But yeah, so for our case, since we are just practicing, so let us stick to this minimum required by the code. Okay, so that's also the reason why some of you use 200, because according to some also practitioners, so they think now 180 is not enough, so they round it off to 200. So just again to accommodate more load. Okay, so again, it was a mistake on my part, and I apologize for that. So please na lang ko change ano niya to 180. I mean, if you change already to 360, so change back to 180. Okay. So yeah, so it has something to do with the wordings. So I mistakenly understood these wordings here. Okay, so what I'm going to do now is that, okay na ba tayo? So nakasabot ra sa akong explanation why you
Yes,
have to
sir.
change back to 180. Okay. So what I'm going to do now, para lang maklaro, no? So I'm going to provide, okay, I'm going to provide an example. So I made an example here para lang din ma-guided in the calculation. Okay, so we have here, for example, so it depends no sa inyong design. So you already have the floor plan. Suppose in your floor plan you were able to calculate, and in the area calculation, so by the way, unsa akong i-instruct sa inyo, are you going to calculate the inside or outside? So we have here, di ba, we have the floor plan, then since nakamani siya nakamani siya wall. Okay, so we have 2 areas here. So in fact, naka siya deliver wall. Okay, so let's say we have this wall arrangement. So there are two areas. So one area is the inside and the other area is the outside. And when we calculate for the area, so we have to use the outside. Okay. So if I instructed you to use inside, so again, I'm wrong with that. So dapat outside ang gamitan. Okay. So if I said it so, then so aside from this one, no, so if you have here, for example, porches, so dili na siya appeal sa calculation because it's an open area. Okay, so only include those closed area, and also for garage, even if it's closed, no, if it not even if it's not a door, so you still consider that as an open area. Okay, so therefore the garage will not be calculated or included in the calculation of your area. So I think na diri ang so let me just check if I already included it here. Yeah, so here, unit load of not less than the specified in table. So this is the multiplier for the area. So it's already in the code. And also take note, no, because I got confused, no. So where I learned those 360 and those inside or outside. So I read both the National Electrical Code and the Philippine Electrical Code. So that's why here I am referring to the Philippine Electrical Code ng mga sections. Okay, so wala na ako refer to National Electrical Code because sometimes different ang mga sections because there are some sections in NEC that may not be applicable here in Philippines. Okay, but for most na part of the code, exactly the same sila, except for the voltage. Then, yeah, so these are are the excluded areas for the area calculation. Okay, so open porches, garages, unused or unfinished spaces, and it should be not adaptable for future use. But if you have a design right now, you have a design part of your building that you think na in the future you are going to close that part or you're going to finish that part. So you have to include that also in your design. I mean, in your area calculation. Okay, so therefore, again, so once we have here, for example, we already have calculated the area to be this one. So we based it in the table and we multiply it since we are working with dwelling unit. So therefore, we have to multiply it by 33 VA. Okay, so this is the demand factor. So here, so for dwelling units, yeah. So you have here 33 volts ampere per square meter. Okay, so that's why we have here, for example, then, so based on this value, no, so we can now determine the general lighting load, I mean, general lighting uh, computed load. So we have here, so this value is just divided by the nominal voltage now in our case. So since we're here in the Philippines, so we use 230. Okay, so according to this calculation, so we have here 17 ampere. So therefore, if we just base on this calculation, if we just based on the minimum requirement, so we can have we just have one branch circuit with 20 ampere na rating, diba? But yeah, so it's up to you, if you use 1 ampere na branch, mean 20 ampere na branch circuit, or you double it to 2 para you have an allocation for future new mga loads. Okay? So in this case, so I made it 2 so that again I have allocation for future loads. Okay, then in here in your loads, no, in your households, so even if it's not mentioned that you have their small appliance and laundry circuit. So since this is dwelling unit, so automatically you will include this small appliance and laundry. Then according to the code, for small appliance, you need at least 2. Okay, then for laundry, you need to have one, at least one. Okay, then they are, although they are rated 20 ampere in a branch circuit now. So, but in your calculation, you are just going to use 1,500 VA. Okay, so because if you are going to use 20 ampere times 230, uh, so that's 4,600. So sobra ra kaya. Okay, again, these are just allocations no, for probable nga loads in this 20 ampere nga branch circuit. But for our actual giving load, so it depends on what you have in your household. Okay, so knowing that, so we just have to include this. So this part now, so for the first part of our total loads, we have the general lighting load. So first is the area, then second is, again, when it's not mentioned, so you have to include 220 ampere and 120 ampere. Okay, so here, so may siyang 3,000, then this one, if 1,500, then in total, so we have here 8,460. Okay, then we have to, because this is part of the general lighting load, so we have to apply this demand factor. So this one, so for dwelling units, we have the first 3,000 at 100%, then 3,001 to 120,000, so 35, then over 120,000, so that's 25%. Okay, so that we have these values now. So the total for the general lighting, although I have not one included here, but in sum of 3,000 and 1,911. Okay, so that's for the first part. So the general lighting, then for the next part is the fixed appliance. Okay, so these are appliances now that are not movable. Okay, so that's why we call it fixed appliance. So by the way, refrigerator is also a fixed appliance now, but we are not going to include it here because uh, refrigerator is already part of this small appliance ng branch circuit. Okay? Although dako na siyang refrigerator no, but since that is part of the kitchen nga load, because if we look at small appliance, so actually here, yeah, so this one. So small appliance are so 1,500. Okay, so the one factor actually it's not here, no, but there's another section for small appliance that that mentions about that. Okay, so I think that's in 210. So if you go here, 210. So for 2.20, so that's for the calculation. And 2.15, so that's for the feeder calculation. Okay, so this is for the small appliance. So this is the general rule. So from 2.10, so although it's not so yeah, so I have here 2.10. So receptacle outlets serve. So what are the loads that can be served? So only those loads in the kitchen, pantry, breakfast room, dining room, or any similar area in your dwelling unit. Okay, so we provide two or more 20 ampere branch circuit. Then shall serve wall or floor receptacle as long as it's covered in these areas. Okay, then yeah, and also receptacle outlet for refrigeration equipment. Okay, so meaning we can include our refrigeration equipment in this small appliance nga, branch circuit. Okay, although there are some exceptions. Okay. Okay, so you have, for example, this one, exception number two, the receptacle outlet for refrigeration equipment shall be permitted. Okay, so the linkage are required, no, just permitted to be supplied from an individual branch circuit rated 15 ampere or greater. Okay, it depends also on your on your the rating of your refrigerator. Okay, So you see, even if it's a branch circuit now, since this is a specific branch circuit, so therefore 15 is allowed. Okay, so not just for lighting branch circuit applicable ang 15 ampere. So but for those specific branch circuit which you know nga dili gid siya mo exceed by 15 amperes. Okay, but if you think that in the future you may replace that refrigerator by higher rating, so that's why you have to think of the future. So you use 20 ampere here. But again, this is just for the exception. So in general rule, so we have to follow this one. So wherein we can include our receptacle na outlet for refrigeration in the small appliance. Okay. So there are two choices for you know. So either way, so it is allowed by the code. Okay, then that's for the small appliance. So that's what I have here. So that's why if you look at this calculation, so you will not see a calculation for the refrigerator. Okay, although in your schedule of load, you may have refrigerator there, but again, dili mo siya actually in your calculation. Then that's for the small appliance. Then for the laundry, so you are required to provide one branch circuit for laundry. Okay, 120 ampere branch circuit. Then also according to the code, so there should be no other load that is being served that by that branch circuit. So let me just, so I think it's here, separate other tabs. So laundry, small appliance. Let me, maybe it's here in laundry. Laundry shall not be less than 1,500. So it's not here also. 220, then 25, 220.2. Oh, this is for National Electrical Code. So let's look at here in the Philippine Electrical Code. So let's go to 220. 220, then track lighting, show lights general. Okay, so this one I think. So by the way, so if you have since if you have a load that is specific appliance, so just like air conditioning as air conditioner, so therefore you have to make it sure your branch circuit is capable of providing power for that specific appliance. Okay, it could be uh, ranges, dryer, air conditioner, refrigerator if you follow the exception. Okay, so muna siya for A, then so dryer and cooking, so na siya sa multiplier. Then for motor load, so you look for 430 and 430 and 440. So it should be here, no? Dwelling other 25, 25, or 210, 210. Let's go back to 210. 210, 11. 210, 210, 1, 11, then 210, 1, 11. Okay, so this one, branch circuit, load available portion, dwelling. Yeah, sure. So here, small appliance. So we already identified that for small appliance, we can include those outlet that are located in the kitchen pantry or the uh, mga countertops. Okay, as long as it's not for counter cooking appliances. Then laundry. So you need to have um, 20 ampere branch circuit, then you have to make it sure this circuit shall have no other outlets. Okay, so meaning only specific for branch laundering a branch circuit. Okay, you can have two, you can have three, as long as it's only for that specific na area. So which is only for the laundering area. Okay. Then also for bathroom, actually, although it's not mentioned there, so you also need to have this bathroom na circuit. Okay. So and also there should be no other um, no other outlet in that bathroom na circuit. Okay, so but in most cases now, probably you have to look at your fansad, your bathroom, even if you call it bathroom, so probably it will not satisfy the requirement of the code as a bathroom. Okay, so you go to Article 100, then look for the definition of bathroom. Okay, so before you are really required to put a single branch circuit for bathroom itself. Okay? But if dili siya satisfy, so therefore there's no need for us to put an outlet in the bathroom. Okay, but if dili siya outlet na, so there should be no outlet in that bathroom. So that's the requirement in the code. But for those seasoned mga designer, so actually they combine these to the nearest nga outlet. I mean, to the nearest nga branch circuit, especially if na siya sa laundry nga branch circuit. Okay? So yeah, so here, so that's for the laundry. Okay, so you need 20 ampere, then 1,500. So you apply the one factor. So the appliances that are provided here. So we have 8 kilowatt range, then uh, air conditioning unit. So night to 1 HP, then 1.5 HP. Then there's one HP water pump. So we have to identify based on this provided ng mga appliance, no? Asa ni belong to small appliance. So there's a code that is specific for small appliance now. I mean, fixed appliance. So we have here this section. This is the one of the name of the section in the National Philippine Electrical Code, appliance load. Okay, so it shall be permissible to apply demand factor of 75% to the nameplate rating load for 4 or more appliances. Okay, so if there are 4 or more, so you can apply 75% demand factor. But if there's just three, one or two, so therefore 100% minimum demand factor. Okay, then other than electric ranges, so therefore, although fixed appliance because we are looking at fasten in place appliances, so therefore those appliances that we cannot move easily. Okay, so that's why other term for this is fixed appliance. And but electric range and clothes dryer and also mga space heating and air conditioning are also fastened in place. But those are the exception in this part of the section because there are also specific section for those loads. Okay, so meaning in this given loads, so we can only consider this 1 HP water pump as our fixed appliance. Okay, so in your design, it could be that there are more. So, for example, you have their air blower. So, air blower is used for evenly distribution uh, of hot air or cool air. Depends on the season. Then could be that you have in your kitchen, trash compactor, dishwasher, or water heater. So those are examples of fixed appliances that that belong to other part of this section. Okay, so in here we only have one, so therefore we apply 100% demand factor. So 1 HP horsepower, 1 horsepower, then we have to look up for its current in the table. So 430. Okay, so we have here follow their current, and this is for the single phase. So we only look at single phase now because we have single phase in our system. So that was 1 HP and 230 volt. So therefore we have here 8 ampere as a full load current. Okay, so that's why we have here 8 times 230. So that resulted to 1840 VA. So this will be our demand for this 1 horsepower water pump. Okay, so for the dryer, so we don't have dryer here. So because again, for most household, probably the necessary a dryer if you have an area for drying your clothes. Okay, so wala siya. So I'll just include it, just put it here, no, just to have a format. Okay, so that we have here included all the necessary mga loading. Okay, so this is the standard format. But if since wala man siya, no, in your actual so in your actual design, so you may have to remove this part of this format. Okay, then for range, so we have here range. Okay, so that is 8 kilowatt. Then according to the so because we can apply demand factor, no, for range. So according to demand factor here, so that's in 220. Okay, so this is for the range. Um, so we have 8 kilowatt. We have 8 kilowatt. Then yeah, so according to this demand factor, so for 8 kilowatts, it belongs here in column B. So therefore, we have to multiply it by 80%. Okay, so 8 times 80%, so we have here 6400 VA. So that, so by the way, here, every time we're done with our, we have identified or determined our VA, so we can already calculate for our branch circuit rating. Okay, so in here, so we already determined this 20 ampere. Then since this is the requirement of the code, that is the minimum for small appliance and laundry, so always 20 ampere branch circuit. But for our fixed appliance, so we have to base it here. Okay, so 1840. So if we are um, so actually maganda siya, no? So if we divide by 230, so balik lang 8 ampere. Then since this is a motor load, so we have to base our branch circuit calculation on article 430. Okay, so in uh, chapter 4, so that since this is a motor load, so we multiply it by 250, 2.5. Okay, so I have here 20. Okay, so since the rating is exactly the same, I mean, exactly or a standard na rating, because we also have to look at, so I think I also included here. Yeah, so this one rating. Well, no? So for motor multipliers, so that's here in 430. Okay, so this is the maximum rating or setting. Okay, so but if so happen nga dili siya mo equate to a standard na rating, so what we're going to do is we have to follow these exceptions. Okay, although it was mentioned maximum siya, but there are some exceptions. So just like this one. Okay, so the first exception. So where the values for branch circuit, short circuit, and ground fault protective devices determined by the table do not correspond to the standard sizes or rating of fuses in 430.6, 240.6. So here, 240. So kanya siyang table. So if wala siya diri nga standard or mean value, so you have to go for the next higher. As long as you don't exceed. So you see here, you can use a higher rating or possible setting that does not exceed the next higher standard rating. So for example, here in our calculation, we have 8 ampere. So if we multiply it by 2.5, because that's for the inverse time circuit breaker and for single phase, so that will result to 20 ampere. So since 20 ampere is the standard rating, so we automatically use this rating. So we don't have to go for the next higher rating. Okay? So that is if there is no problem with starting, because again, there will be other exception that you can apply. So if ever starting of the motor is problematic, okay, with using this rating here. So I think it's here. Yeah, so because it's also mandated that the motor branch circuit or short circuit or ground fault protecting devices shall be capable of carrying the starting current of the motor. Okay, so you also always have to look at the starting current. So if once starting is a problem, so we have to look at these exceptions. Okay, so if you are using a non-time delay fuse, so you can use uh, so you can increase the what you call that rating as long as the lithium exceed by 400. So this is for 9 time, um, 400%. Then for time delay, so this is not the one we're using. And for so this one for inverse time circuit breaker. So that was 250% now, but we can increase this until 400%. You see the Hokkaido allocation, okay, or room for increasing the rating. Okay, but that is again only if you have a starting problem with the calculate rating in the given table. Okay, so that is for greater than 100 ampere. I mean less than 100 ampere. Then for greater than 100 ampere, so your multiplier should not exceed 300. So you only have a room 250 to 300. Okay, so but since ito siya na rating, what we have calculated here is just 20 amperes, so significantly lower than 100 amperes. So therefore, we can use to 50% to 400%. Okay, so that's for the fixed appliance. Then again, we don't have range. Then here's 8 kilowatt. So 8 kilowatt times 6400. So 6400 divided by 230. So I have here 27.82 or 28. So therefore, the so this time since this is not a motor load, so I don't have to look it up to the values in 440. Okay, so I'll just base it directly to this table. Okay, then I go for next higher because again it's not a motor load. So 28 again, so I'll go for 30. So that's the next higher NINGA rating. So I'll go for this rating here. Then so for this one, heating or cooling. So it depends no, on whichever is greater because this belongs to this part of the code. So non-coincident loads. Okay, so if it's unlikely that two or more non-coincident loads will be used simultaneously, so we just use the largest of the two rating. Okay, so but in here, so wala man tayo heating, we only have uh, air conditioner. Okay, so there are 3 air conditioning units there, and 2 for 1 HP and 1 for 1.5 HP. So that's why we have here 8 again for 1 HP. Then that's 10. If you look at the table, 10 for 1.5. So I think I moved already now. So it's here 430. Okay, so this one 430 for 1.5 horsepower at 230 volts. So we have 10 amperes. Okay, so that's why we have here 10 amperes as well. Okay, so that's just one. Then can siya multiply by 2 because there are two 1 HP horsepower. Okay, but even if I multiply it by 2, so that is just for the calculation of the demand. But when you provide branch circuit, so you have to provide also one for each of these each of these air conditioning unit. Okay, so that is provide 220 ampere. So we provide here 20 ampere because same with this one, no? Exactly if I multiply 8 by 2.5, so I'll get 20 ampere. Okay, so since this is standard, so I'll use this as it is. Then for this one, so I have 10 times 2.5, so that is 25 ampere, 25 ampere also. So another standard value. For 25, so I have higher value. But I just have to tell you that 25 ampere is not common in the market. So that's why in most calculation, so if you encountered this value, so they used, you can use 30 ampere. Okay. So because again, it's not available, usually not available in the market. So now we already have accounted or our load, all our loads now. So in your design, it could be that you have there specified how many lighting loads you have, how many COs you have, but in your calculation for so for your feeder, it will be based on this one. Okay, kato siya ang 180 that we mentioned earlier was just for the determination of how many outlets you can connect to a single branch circuit. So that is you divide, no? You divide the VA for that load uh, by the number of outlets. Okay, so we total this one, no? Total all the uh, general lighting loads, fixed appliance, dryer, range, heating or cooling. So it will result to this value. So 19.131 kVA. Okay, so we base our calculation now for the feeder on this value because this is the value now after the application of demand factor. Okay, so but we have to specify now how many circuits we really need. Okay, so here usually for for lighting loads or mga general lighting loads, so we just need to wiring a branch circuit. Okay? So it doesn't have to have a grounding because ang mga lighting loads are located in the ceiling. So very rare lang siya ma-touch by the user or by the personnel. So but for other other loads or outlets. So we have to provide three-wire branch circuit. So this third wire will be used for the ground. Okay, so two wire will carry the normal conditioning current. Then the third wire will carry the normal conditioning current. So that is if there is a ground fault or short circuit. Okay, then yeah. So according to this ano siyang mga blue na color. So just So there are 620 amperes, three-wire branch circuit, then two 20 ampere na two-wire, then 125 and 130. Okay, so again, if not available, so you can make it 230 ampere na three-wire branch circuit. Okay, so now for the calculation of the service entrance conductor, so we based it on the, of course, the current of our load. So for us to obtain the current, so we have to divide this VA by 230, right? But if you have a motor load in your circuit, so in your calculation, so you have to consider that motor load as a continuous nga load. So that's why we have to add here 25%. Okay, so that is for the additional nga load of the motor. And look for the largest motor. So we have here water pump, we have here AC 1 HP and 1.5 HP. So since kanima siya ang pinakadako na 1.5, so I use this value for the additional 25% of my load. Okay, so now the total 19131 plus 25% of the biggest load, being the biggest motor load. Okay, so if you have, let's say you have here heating ko ano, let's say we have here a dryer or a range. So your range has iko ano, it's so actually it's bigger. So even if the range is bigger, no, so we don't use this one. So we only ano, add 25% of the biggest motor load. Okay, so if you don't have again, you don't have load. I mean a motor load, so you don't have to add here 25%. But that is very for modern nga mga design. So nalagay tayo mga motor load karon. So 25%, then the result is 86 amperes. Okay, then if we are going to use THN, so we use this 22 mm squared. Okay, so 22 mm squared, so that is number 4. So you just have to look it up online sa mga equivalent values. Okay, although here in the National Electrical Code, so in chapter 9, so there are conversions now that you can use, but the problem is that these are not trade sizes. So for example, for number 14, so I know that in trade size value of 14 AWG, so it should be 2.5, I mean 2.0. Okay, but here, so 2.08 ang values because this is the actual giving conversion. Okay, so not based on trade sizes. So in trade sizes, it could be that it is being rounded off now. So also for number 12, so supposedly this is 3.5 mm squared, okay, for the trade size, but in here, so the actual conversion is just 3.31. Okay, so the values here may be different now from the trade sizes, but you just have to look for the closest value. Okay, but this is the actual conversion. Okay, so for number 4, so that is again this value 22 mm squared, but if you look at the table, so the value here is just 21.15. Okay, so based on 22 mm squared, so where's the table? 310. Okay, so 22 mm squared, or again, that's number 4 AWG. So THN, so it's here in 90 degrees Celsius. So we have here 90 amperes. Okay, so that's why we use 22 mm squared because we have here current maximum. Okay, for 22 mm squared daw nga THN must be in powered. So this is for the service entrance. So we don't have to apply kasi siyang 1.25% of this value because this is already the 1.25% siya. Although we're only considering the motor load as our continuous load, then all the rest are considered uh, non-continuous load even if they are actually continuous because again this is for the service entrance, so we know that it's very rare now that all of your loads will be used simultaneously. Okay, so and also this one kaya siyang 8.0, so this is the minimum mga required uh, grounding conductor. Okay, so 8.0, so that's why automatically you have here 8.0. Then also, since there are here 3 wires, so therefore, if this is 20 ampere yung branch circuit, so you have to look it up online, I mean, in table, sa man siyang conductor. If this is still the HN, so therefore, you can use number 3.5 mm squared. Okay, this one still 3.5, and also kani siyang 30, no, it can be supplied by 3.5, but it's already bottleneck. Okay, so probably you have to increase your conductor size for this one. Then the other kani siyang pair niya, so if your conductor or the conductor no, that carries the normal current is 3.5, so you can use for the grounding slightly smaller na size, so that is 2.0. So actually 2.0 ang minimum conductor that you can use in your branch circuit as a ground conductor. Okay, so since this is the feeder, so for the feeder, the minimum is 8.0 mm squared. So that is also actually 8 AWG. Then for the service equipment, so we now have determined the requirements and the conductor size of the feeder. Then for the service equipment. By the way, these calculations here, no, kanisya tanan dire, are all for your service. Okay, so see here. So you identify, kanisya, you identify the ratings of your circuit breakers. Okay, because these circuit breakers are also located in the panel board. Okay, then this one, so this is the conductor before the circuit breaker, so service entrance conductor. Okay, then, yeah, so you also have to determine the protection for that service entrance. So we base it in this calculation. So we have here the total load, so that is 19131. Okay, so 19131. But we have here an additional of 150% uh, of the largest load. Okay, so that's because supposedly this kind of calculation should look like this. So if you have the largest motor here, okay, so largest motor, and you have here all other loads. It could be composed of other motors or heating or other ng mga general appliances. Okay? In our calculation for the conductor, so we have to look at so this 1.25% of this load plus this amperage here. Okay? So that is the calculation for the total for the feeder ng conductor. So, ano siya? But for the rating, so if we have here protection, for the rating, we based it on, so same with this one, we have to separate our calculation. So we still have this amperage, but this one we have to, because this is a motor load, again, this only applies to motor, no? If you don't have motor, so you can't do this one. So just use the total current. So for this one, since this is a motor load, so we have to multiply it by 25. Sorry, so this is 1.25 now times FLC. Then this one, because we use 250%, so we multiply it by 2.5 times FLC. Okay, then plus again the amperage. Gera, you are turning on your mic, so there's some feedback. Amperage. Okay, so this is actually the calculation. Okay, so for the protection, and this is for the conductor. Okay, but in this calculation, because since we already have the total, so why not use this one? Okay, so since we already have here the total 19131, so we can just use this one, but we just have to add the excess of that calculation, so of this calculation. So if we add this one to this amperage here, so 100% of this FLC to the amperage here, so that will already be the total. Okay? So total na siya plus just 25% of this one because we removed 25% of this one just to add the 100% to the amperage. So therefore, you have to add 25% here of the motor. Okay, that's for the conductor. Then for the protection, so again, we can use the same kind of formula because we have the total already available. So we can use, so we remove the 100% here. So what remains is the what remains is the 2.5, I mean 1.5%. So that's 150% of your motor. Okay, so that's the reason why this one has 150%. Again, that is because we are using inverse time circuit breaker. So if for example we are going to use protections other than inverse time, so let's look for the values. Okay, so here let's say we're going to use this non-time delay fuse. So therefore, for single-phase motors, so we have here 300%. So therefore, in our calculation here, so we'll have 1931 for the total, okay? Then plus 200% of the largest motor. Okay, so that is 2,300 VA. Okay, then just divide it to 30, then that's your current. Okay, so current that your circuit breaker should be able to carry. So 98 amperes. Okay, so you can use if you look at the standard, so you can use first 240. So you can use 100. Okay, so but probably this is also one bottleneck already. Uh, so since wala ka mataas, atong calculation dere wala talaga include og spare. So what happened? Okay, so wala talaga include og spare. So you also have to include that one since my calculation is only based on the given loads here, so without considering the future loads. So you also have to include spare here so that probably after applying or including spare, so your service equipment will increase, so will exceed will exceed to 100, so that your rating will be greater than 100, or you use 110 or 125. So again, that is just for uh, considering that you have a future load. Okay, so also we can specify its frame rating. So let's say we have 100 ampere trip. Then if we consider that maybe in the long run we double this in the future we double this rating that we have right now, so we can use a 200 ampere trip frame. So I think that's standard. Yeah, so it's also standard. So sorry, so this is frame. Okay, again, just to accommodate increase in rating. So you remove this 100 ampere clip na breaker and replace it by 125, 150 as long as it is less than 200 ampere of the frame. Okay, so 2 pole, 40 volt multi-case circuit breaker. So that's how we calculate our load. So dapat yung question side, nasabtan na ba?
Excuse me, sir.
Yes, you have a question?
Pwede mo nga sa kanang copy sa katong kuan, sir? Kato bitong naay kuan sa tanan, sir. Kato mga calculation, sir.
You mean this Word file?
Yes, sir. Kana, sir.
Actually, ako na siyang ako na
Ah,
siyang upload sa Canvas, but wala ka man ako
yes, sir.
nahuman so that's why naka-share.
Sige,
Wala
sir.
na
Thank you, sir.
nakita mo ba nga rules, so dapat tama siya iban nga rules to follow. So manang wala pa na ako finalize. But I'm going to put this in Canvas.
Excuse me, sir. Sa
Thank you, sir.
PEC lang jud magbase, sir.
Sa to sa
PEC.
again, I look at the sections in PEC because I got confused on asa to na ako nga na-recall to na ako mga learnings, no? Was it in NEC or was it in PSC? But after reading the same sections, exactly the same lagi sila. So you can base your if you so exactly the same content section, but the section naming is different. And also there are some sections in NEC that is not available in PEC because again because probably of the different weather, so man siyang gi-remove siya in PEC. But if you just focus on sections here in NEC that is applicable to our case, so the same lang ang imuhang result if you look at the sections in PSC. Okay, so either way, so correct lang yung calculations. Okay. So other thing to note. So I noticed after after trying my own design in schedule of load. So I noticed nga if we are going to include all the loads in the schedule of load description, so hugaw na kayo tanaw ng ato ang design. So we have their uh, format. Sorry. Okay, so probably we have here the number, the description, then we have here probably some kind of information, and yeah, so the conductor and the remarks. So I noticed that if we are going to include all the descriptions of a certain load, for example, I have here one, or let's just make it 10, 15 watt fluorescent pin light, then mag-include po ko diri og uh, 5 fluorescent lamp. So I noticed nga crowded na kayo siya, no? And hugaw na tanawon ang design. Okay? So although I mentioned ako mentioned before that you have to specify all your loads here, but you can just do what you did, no, in your design, where you just put here lighting outlets and convenience outlet. So just to make it just to make your design cleaner. Okay, but anyway, we are still going to use this information for you still have to specify pila siya ka, for example, 15 watt pin light, pila siya ka fluorescent if you have. Okay, so let's say 40 watt fluorescent, because later on we are going to have a what do you call that? We are going to have a cost estimation. Okay, so this will be the final part, the cost estimation. So therefore, you have to determine the number of outlets, the number of the ratings of those outlets. Okay, so but in your schedule flow, just to make less clutter, so I want you to just rename this to general niyang namings. Okay. Then what else now? All motors. Napo ko yung mga na-mention probably before that may have may have been that I may have contradicted right now today for today's discussion. Can you still recall para ma-clarify na ako karon? Okay. Okay, so with wala na, no? That's it. And again, I'm going to publish this in Canvas later on. Okay, so that's it. And thank you everyone for attending the class. You may now leave.
Thank you,
Maraming
sir.
salamat.
Thank you, sir.
Thank you, sir.
Thank you, sir.